Hi, my name is Ian Robertson. I'm a Professor Emeritus of Structural Engineering at the University of Hawaii at Manoa. I served as the lead author of the third edition of the Science Plan for the Natural Hazards Engineering Research Infrastructure, or NHERI. This short video is intended to introduce you to the three grand challenges presented in the third edition of the National Science Foundation's NHERI Science Plan. There were three primary drivers for the development of the third edition of the NHERI Science Plan. These issues were not adequately addressed in the prior editions. The first was to more holistically incorporate the social science aspects of hazard mitigation, represented by the Converge Center headquartered in Boulder, Colorado. Members of Converge come from all areas of social science research and practice. Their advice and input are invaluable for many engineering research projects, particularly those focused on mitigating the effects of natural hazards on our communities and their infrastructure. Without social scientist guidance, engineers may develop solutions that are never adopted or are inappropriate for the communities for which they were intended. The benefits of collaboration with social scientists has therefore been added throughout the third edition of the Science Plan. The second driver for this update of the Science Plan was the inclusion of post-event reconnaissance and research, represented by the 8 Extreme Event Reconnaissance and Research Networks, or EERS. These EERS include everything from geotechnical, structural, nearshore coastal, social impacts to public health. Post-event reconnaissance and research is often the trigger for new research projects, so sharing information on these groups and their objectives will help generate interest in these research opportunities, particularly for junior researchers and practitioners. The third driver for updating the Science Plan was the increased maturity of the simulation tools available from the NHERI Sim Center via DesignSafe. Prior Science Plans mentioned simulation and its important role in hazards research. The third edition emphasizes this message and encourages the use of the extensive suite of tools now available from the Sim Center. Now let's discuss the three grand challenges presented by the Science Plan. The first focuses on understanding the natural hazards that threaten our communities. It reads, identify and quantify the characteristics of single, co-occurring, and compounding natural hazards, whether of geophysical and/or atmospheric origin, that have the potential to harm people, damage civil infrastructure, and to disrupt communities. In the past science plans, and to a large extent the focus of NHERI research, has been on single events, possibly incorporating multiple hazards. The third edition emphasizes the need to consider co-occurring hazards, such as landslides triggered by earthquakes, and compounding hazards, such as repeat hurricanes affecting a community in close succession, possibly overlapping with a health pandemic, for example. Past science plans limited NHERI's scope to earthquakes, windstorms, and the associated events such as tsunami and storm surge. We have changed the focus to geophysical, which includes earthquakes, landslides, and similar events, and atmospheric origin, which includes hurricanes, tornadoes, derecho, other high wind events, flooding, including coastal, riverine, and pluvial, as well as consequences of heat extremes, such as drought, and wildland-urban interface fires, which all originate from atmospheric conditions. The emphasis is on all natural hazards, which have the potential to harm people, damage civil infrastructure, and to disrupt our communities. This intentionally broadens the focus from just buildings, bridges, and infrastructure networks to the social impacts on the affected communities. We need to make sure that our engineering solutions are socially appropriate and will indeed improve overall resilience for our communities. The second grand challenge is focused on how these hazards affect the exposure and vulnerability of our communities. It reads, assess the exposure, vulnerability, and adaptive capacity of civil infrastructure and social systems in areas threatened by natural hazards. The first step, therefore, is to assess our exposure to these hazards. How vulnerable is our existing built infrastructure? How vulnerable are our social systems? What capacity do we have to adapt to changing and unpredictable hazards? How prepared are our communities to weather the storm and recover stronger than they were before? The third grand challenge is to prepare for future hazards by developing a diverse hazards workforce that can help to develop the technologies and tools to support the design, construction, retrofit, and operation of equitable, sustainable, and resilient civil infrastructure for the nation. It's not enough just to develop solutions. They have to be accepted by the communities for which they're intended. So working collaboratively with a diverse group of architects, engineers, social scientists, community leaders, policymakers, and politicians is the best way to ensure success and strengthen our resilience ahead of future natural hazards. We hope you will use this QR code to download a copy of the third edition of the NHERI Science Plan and see how your research might aid in addressing these grand challenges. And keep in mind that, as noted in the Science Plan, there is no such thing as a natural disaster. There are natural hazards that present a life safety threat to communities and their infrastructure, but they only become disasters if the community is not adequately prepared for the hazard. We cannot prevent natural hazards, but we can reduce the likelihood that they become societal disasters.